Okay, good evening, everyone. Good afternoon. My name is Marcia Taylor, and I am in the department called Center for Marine and Environmental Studies within the University of the Virgin Islands. And I work for a program that is funded by Sea Grant. Many of you might be familiar with Sea Grant from other places. It's funded by NOAA, and my job is to do outreach and education related to the marine environment. So today I'm going to be talking about climate change, global climate change. I'm going to talk about just generally what it is real quick, and then I'm going to talk about damages or impacts that we have seen or likely to see to the marine environment, particularly here in the Virgin Islands. And then I'm going to take the opportunity to also talk about some of the education programs that I've been involved with dealing with climate change here in the Virgin Islands. So, real quick, greenhouse effect. We know that the sun rays come in, they warm the atmosphere, the ground. Some is absorbed, some is re-radiated, and greenhouse gases capture a lot of the heat so that our Earth stays at a relatively comfortable temperature. Without the greenhouse effect, our Earth would be much, much cooler. The problem comes when we have a buildup in greenhouse gases, and that absorbs, it collects a lot more heat. And that's what's going on now. We have a lot of carbon dioxide being pumped into our atmosphere, and this is causing our Earth to heat up. So carbon dioxide isn't the only greenhouse gases. Some of the others are methane, nitric acid, water is even one. But we're going to be talking largely about carbon dioxide because that's the one that we have really increased the amount going into the atmosphere and the one that we can control. And that's so important right now. So let's start. Where does all this carbon dioxide come from? Well, it comes mostly from electrical generation. Okay? During this process, emissions have a lot of carbon dioxide, and this is building up in our atmosphere. So solutions, better technology, cleaner burning coal, and energy conservation. So how does this carbon dioxide buildup, this global climate change, affect us? Well, the Intergovernmental Panel of Climate Change, which is a group of experts from all around the world, they meet on an annual basis and they talk about climate change. What are we seeing? What are we going to see? These are the main things that they've identified. These are really general. We'll get specific. The temperature is going to increase. Obviously, we've seen that. We've already gone up over 1 degree. We're going to see more droughts, more floods, more extreme weather conditions. We're going to see glaciers melting, water shortages. We're going to see more health problems. Tropical diseases are going to be moving into other areas where we haven't seen them. We're going to see sea level rise and flooding of our wetlands and coastal areas. Some ecosystems will disappear, and we're going to see changes in agriculture. Okay, so we'll be talking about some of these as they relate to the marine environment. Let's start with sea level rise. Okay, so as the Earth gets hotter, the glaciers are going to melt. This is a lot of fresh water that's going to be going into our oceans. Okay? But that is not the only reason why the sea level is increasing or rising. Water takes up more space as it gets warm. Okay? And so that is actually a significant part of why we're going to see sea level rise. This is an example from a hot water heater. You can see at 70 degrees how much space the water takes up, but at 180 degrees it takes up a lot more space. So we've got melting glaciers and snow, ice, but also expanding water. Because of that, well, in addition to that, as we lose our ice, what's happening is we're going to have less reflectivity or albedo. And because of this, more of the light is going to be absorbed by the Earth and less reflected. And so that's going to increase the warming. Okay, so the IPCC's prediction is that we will see anywhere from a few inches to a few feet by 2100. That will mean that if it's 2 feet, we could lose 10,000 square miles. If it's 3 feet, Miami would be inundated. This is going to affect erosion, wetlands being flooded, our freshwater supplies. And a lot of our population lives in coastal areas. So this is going to upset a lot of people living in coastal areas. We don't have the answer of exactly how much it's going to increase because we don't know how much of the ice is going to melt. And it's a little more complex. And so this is the best we can do at this point. Okay, so let's talk about wetlands. As the sea level increases, the wetlands are going to be inundated. Around here, that means our mangrove areas, our estuaries. Why is that important? Well, these areas are really important for a lot of reasons. They're important to our marine resources. A lot of our fish and invertebrates use mangrove areas and estuaries as nursery grounds. And so if you destroy them, that's going to impact a lot of marine organisms. These estuaries also help to filter our water as runoff runs down through our estuaries. A lot of the sediment is caught in the estuary, making the runoff water a little bit cleaner, so it helps keep our water quality clean in our bays. These estuaries are also home to a lot of species that live there all the time, birds and vertebrates and other species. So it is important if we lose our wetlands. Some predict that by 2080, 33% of the world's wetlands will be lost due to sea level rise. Now, new wetlands will be formed, but it's going to take a while for them to really become functioning, provide the services that these wetlands do right now. Okay, so one of the big impacts is bleaching, coral bleaching. Now, probably most of you are familiar with corals, and you understand that coral lives at the upper level of its temperature range. And even small changes in the temperature causes the coral to what we call bleach. And that just means they expel their zooxanthellae, or the microscopic algae that live in the tissue of coral. It's a symbiotic relationship where the coral gets nutrients and the carbohydrates from the algae. But for some reason, under a stressful condition like high temperature, these organisms expel their zooxanthellae, causing them to look white. Now, they are not dead, but if the temperature doesn't come down within a few days, they will die because they have other mechanisms to feed, but this is one of the primary ones. And without that, they wouldn't be able to survive. We had a mass bleaching event in 2005. There were smaller ones before that, but this is the one I really remember because it was dramatic. You go down and you just see white all over. And over 95% of the corals, it was estimated, well, depending upon the area, bleached. Okay, so. All right, so why does it matter? Okay, so since in 2005, most of the coral came back. They were able to grow back their zooxanthellae. However, the coral was weakened, and we lost a lot of our coral. They estimate 60%. Again, it varies depending upon the depth and location. Of our coral was lost during this one event, but not necessarily from bleaching, but from the disease that occurred after. Because these corals are so weak, they were very susceptible to the diseases that they would normally be not affecting them. So we had another bleaching event in 2010, and experts tell us that we're going to have more bleaching events and more frequently, to the point where they're probably going to be annual. So climate change is the biggest threat to our coral reefs, although there are other threats as well. We have a lot of coral diseases. The number of coral diseases seems like it's increasing since the temperature has increased, but we know that certain diseases actually do better. They are able to infect more corals with increased temperature. So these are some of the diseases. There's white band, there's black band, there's white plague, and there are other diseases that we're studying all the time. There seem to be more of them, and the temperature increase is not helping. Okay, so I'm just going to mention this. This isn't from coral. This isn't from climate change, but we also, in addition to the bleaching of corals, we've also had some other impacts to our corals. This was one of the major grazers on our coral reefs, diadema, or the long-spined sea urchin. And in 1983, 1984, we had a massive die-off of diadema. Because it was the major grazer, that meant that the algae that normally grow on the coral now is not being clipped short. So this algae is actually overgrowing the coral. And it also means that the coral substrate, the dead coral substrate, is not available for smaller corals to settle on. So the algae is detrimental, and the sea urchins were the key, and they have died off largely, over 95%. And since then, we've had some recovery. I read a paper in 2016, there was a study, and it estimates that we have about 12% of the pre-die-off population of diadema now. And so it's just very slowly coming back.
Was that die-off because of climate change?
No, that's what I said. It doesn't seem so. Seems like it was a vector in the water, because they looked at how it was spread, and it seemed to be going with the currents. And this was in '83 too. But we don't know. Scientists really don't know what caused this. Okay, so this, there are also problems with our reefs with other grazers. The fish are, some of the fisheries are being overfished, and these organisms also are not able to take up the slack. And because of that, we have coral reefs now due to climate change and the overfishing and the diadema die-off. We have corals that are now overgrown with algae. Now you can see here the algae, but you see this stringy stuff. That is a brown alga, and it's overgrowing our reefs. We went from coral reefs that were largely live coral, 30 to 80% live coral, to a point now where generally most of the reefs are less than 10% live coral. You can see this Dictyota, this algae overgrowing this coral. That's where a lot of our reefs look, and that's a problem. Now, these brown algae, we don't know. We know in this case that they're there because there's a lack of grazers, but we also have other brown algae that are blooming, such as sargassum that we're finding washed up on the beaches. And some think that this might also be due to climate change. There's more carbon dioxide in the water. The water has a higher temperature, and those things combined seem to favor some of the brown algae that we're seeing, the sargassum, but also I'm seeing other species now that are growing on hard bottom areas that weren't there before. Okay. In addition to coral bleaching, we also have more frequent hurricanes. Not more frequent, I didn't mean to say that. More powerful hurricanes. There's a question whether they're going to be more frequent or not. Most people don't believe they're going to be more frequent, but we do know that they are more powerful. Because of that, we're going to be losing a lot of marine resources. Here's a picture of a coral reef after the hurricane goes through, kind of broken down into rubble. The waves pound, especially the shallow water corals. The deeper ones tend to do a little bit better. In addition to the direct pounding from the waves, there's a lot of other things that go on with hurricanes. You have more rainwater, so you have more runoff getting into our bays, and because of that, more dirt. And we'll talk about that in a second. I think I've got some more pictures. Okay, so these are some pictures from my colleague from the National Park Service on St. John. Jeff Miller sent me these, and these are before and after pictures after Hurricane Irma. You can see on the left, before, nice healthy live coral, and on the right, basically rubble. So we took a beating. So in addition to the physical damage, as I mentioned, there's a lot of runoff. And this is pretty typical during any rain event. We have a brown coastal areas. This is largely from soil that's been stripped of vegetation, people developing, putting houses on, and just taking the vegetation off the soil. And as the stormwater comes through, it's picking up the sediment and carrying it into our bays. Well, coral reefs and other organisms have evolved to live in clean, clear water. And they don't do well under these conditions for a number of reasons. Number one, we mentioned that coral has algae in its tissue, so it needs light in order for it to make food, the algae. And if we have a dirty water, the light is not going to penetrate. The dirt itself can settle on the coral or other benthic environments. And this is a problem because corals don't like to have dirt settled on them. They do have a mechanism to clean themselves. They give off a mucus, and it sloughs off the dirt. But this is done at great expense to the corals, and this is energy that they're using for this that they now can't use for growth and reproduction. So that's a problem. In addition to that, the dirt also has nutrients in it, which promotes the growth of algae, and this can also cause algal blooms. So coastal runoff is a problem, and of course we have more runoff with hurricanes. In addition to that, this runoff also has bacteria in it. A lot of the soils in the Virgin Islands aren't really good for septic leach fields, although we put them in. And so after heavy rains, we have a lot of bacteria in our water, and also other things. Anything that the rainwater runs over, it picks up and carries into the water, and that can be oil and gas, toxins, whatever's on the ground. And of course with hurricanes, we have a lot of storm water. Okay. All right, so let's move on to another part of climate change that impacts our marine environment, and that's ocean acidification. As we get more and more carbon dioxide in our atmosphere, the ocean also is increasing in the amount of carbon dioxide. And you see this reaction here. Carbon dioxide combines with other things, forming so that the ocean waters become more acidic. Now this is a problem because acid actually dissolves calcium carbonate, which forms the shell of a lot of organisms like clams, other gastropods, corals, some of the plankton that we have. All of these organisms that use calcium carbonate now will find it more difficult to form the calcium carbonate, or its shells will be thinner. There have been studies showing that sea urchins exposed to this acid form a very thin, fragile shell. So ocean acidification is a problem, and it's happening now. The pH has dropped by 30% in the oceans since, let's see, I knew when that was. Well, over the last many years, and they're expecting 100 to 100% increase by the end of the century. So we can expect to have more acid, oceanic acid water in the future. All right, so ocean acidification, also a problem. All right, so let's talk about some of the other habitats that are going to be impacted by climate change. One is our beaches, and the turtles that live, or not that live, but that use our beaches. Of course, as sea level rises, we're going to have less and less beach area, so this can be a problem for turtles. This habitat then would be degraded for the sea turtles, and we have 3 species here, all of which are on the endangered species list. Climate change directly affects them because, number 1, as I mentioned, the sea level rise and the habitat. Number 2 is the temperature. It's found that whether the sea turtle's eggs become a male or a female is dependent upon the incubation temperature. And the higher the temperature, the more males are going to be born. Okay? So in Florida, loggerheads, they're seeing a temperature increase, and already they're producing, 90, I got it mixed up. It's increased temperature actually prefers the females, and so they're finding now that their eggs, 90% of their eggs being hatched are females. Okay, so we can expect to find more female turtles, and if the temperature is too high, the eggs won't even hatch. So that's going to be a problem as well. And they estimate that it needs to be, if it's over 34 degrees centigrade, that eggs won't even be viable. Not only one sex, but not viable at all. Okay, so in addition to sea turtles, we have changes to our fisheries, which we are starting to see, but we'll see more so in the future. Some species will disappear. Other species will just go north, so we won't see so many here. They'll start going up into colder waters. And also we see the amount of plankton is going to be changing, and so that will impact the fisheries as well. So there will be changes to our fisheries to the point where we'll be losing, I would say, a significant amount of fish depending upon the temperature change, but it's not going to be any more. It's only going to get less. They're going to be impacted. They're going to be moving north, and they may or may not survive depending upon the ecosystems that they find in the northern waters and whether they have what they need there. Okay. All right, so other changes that I didn't mention. As the temperature increases, the amount of oxygen that's soluble in the water will decrease. What changes will we have for that? We don't know exactly, but it's not going to be good. All the marine creatures need oxygen in the water because they breathe just like we do, and if there's less dissolved oxygen, that definitely could have an impact. It's predicted that we'll have more incidences of ciguatera. Ciguatera is a type of fish disease which is caused by a dinoflagellate, and these dinoflagellates, if they're eaten, if a fish eats a lot of them, it accumulates and it has a toxin, and if you eat that, you could get very, very sick. We haven't seen that yet. I don't think that our ciguatera incidents have gone up yet, but the experts tell us that we should expect it. Changes in our migratory bird routes. Birds aren't going to want to be down here where it's hot either, and they may change and go a little bit more north, so we may see less birds down here. And of course, the rainfall patterns are going to change too, which are going to mean we're going to have more rain in certain times and less in others, leading to droughts and flood events. Okay, so in general, there are some things that the IPCC recommends: producing more efficient vehicles, reduce vehicle use, improve energy efficiency, develop carbon capturing processes. This is something that we haven't really done, but there's research being done now to try to figure out how we can capture some of this carbon out of our atmosphere. Moving away from traditional generation of energy, moving into other renewable sources, solar power, also nuclear energy. And of course, deforestation, if we can prevent that or if we can plant trees, the forests actually naturally capture carbon out of the atmosphere. And so as we cut down our forests, we are taking that ability away. And population growth. If we can get that under control, that would help as well. So, particular to the marine environment, what we can do is start managing our shorelines. We know that even though everybody wants to live on the coast, not everyone can, and we need to plan for that. More protected areas. If we can reduce some of the man-made impacts by creating protected areas, this will help as well. Some of our marine organisms that are under stress. Decrease non-point source pollution, meaning more careful way of developing our property. Increase shoreline barriers such as mangroves, plant mangroves, and promote these areas because they're natural buffers and can help us. Now, when I talk to classes, I want to give them things that they can do as well. And so what I tell them, you can do here. You can do these things. These are things that you have control over that you can actually help. Now, maybe you're not going to see a decrease in carbon dioxide in your lifetime because it's going to take a while, but it doesn't mean that you shouldn't actively work towards that. And so I give them this list of things to do. And then we talk about climate change. So I want to talk about a program that I've been involved with for several years called the NOAA Climate Stewards. It's a NOAA program, and their purpose is to help increase awareness about climate change, especially to educators, both formal and informal educators. And if the educators know what's going on, then they can pass it along to the students. So they've developed this climate literacy book, which helps educators to understand the concepts of climate change and allows them access to scientifically credible data and allows them to make informed and responsible decisions. So I became a member, or I started going to these Climate Steward webinars, which are held in the evening, and there's usually 400 people on the webinar from all across the country. And they occurred on an annual, monthly basis. And we would learn about all kinds of climate change issues. You can see, well, in this is a few years ago, there were 200 educators from 46 states, Puerto Rico, the Virgin Islands. That was me. I was the only one, and I'm still the only one in it. But it's a great program. And this program provides resources for teachers. It provides education or professional development so we understand the issues and we can transmit the data better. They get mini grants, which I've gotten 2, and I've applied for another one this year, which I'm expecting to hear on this month. And it's really a great program. They also have a book club where we can talk about different climate issues, and it's really kind of a very interesting program. So in 2013 was my first climate education program. And what I did is I worked with a group of students from the Educational Complex, which is a school right across the street, one of 2 high schools here on St. Croix. I did 8 weeks of climate education with them. I would go in once a week for about an hour or so, and we talk about different climate issues. I found that here in the Virgin Islands, there's not a lot of climate education. And some students would kind of know what it is, and others didn't have a clue. So I'm glad I had an opportunity to talk to these students. And then I divided them up into 3 different groups, and they worked on their own climate education projects. Now, one of the ways I like to work with students is to give them information, but then have them teach it to their peers or younger students. And so what we did with this project is we divided the class into 3 different groups, and each group had an age level, whether it was elementary, junior high, or high school. And I told them to come up with methods that they thought would relate to that age group. And then once they did it, we would go into the elementary school or whatever, and they would do their presentation. Of course, I'm looking at all their work to make sure it's okay. So more about that. The other thing, when they did that, they decided, well, the group that was working with the younger students, they wanted to do a puppet show on climate change. The group that was working with junior high wanted to do a rap. And then the older group wanted to do a play. And so then they made presentations for their peers at their school on climate education. And they also, as I mentioned, went to the elementary school and the junior high to do the other things. We also had an opportunity to make a presentation at the Coral Reef Task Force meeting, which is held in the Virgin Islands, I think, once every 3 years. And that's that picture on the right. A couple of my students making a presentation. Down at the bottom, there's a picture of a group of students that went to an elementary school to do some activities with them on reuse, looking at typical garbage and how do you make it into something that could be reused. And then we also did some beach cleanups, and here's a picture of one we did on the water in the mangrove areas. Okay, so a little bit more about the classroom discussions. I found that using the film An Inconvenient Truth was one that they related to, and it's a very long film, so I divided it up into different segments, and we watched a part of it during several of the class sections, and I gave them some focus questions so they could look and pay attention and find the answers. And then we did a discussion on that as well. And of course, we discussed all the typical things related to climate change, proxy data, glaciers, coral bleaching, sea level rise, difference between weather and climate, talked about hurricanes. And then we read a book. Now, these students, they really related to this climate change book. It's like a little tale dealing with fish and crabs, and they talk and this and that. It was called Fish Tank. But they really got into it. They enjoyed it. It was a very simple book. So we read that and we discussed that as well. So that was our classroom things. And then a lot of the students did their own projects. And this is one of the video. And hopefully this will be playable.
Good day, I am the spokesperson for Plastic Defeaters, and I'm here to talk to you about plastic. 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 Plastic.
Hey guys, did you know that there's 2 harmful chemicals in plastic, such as phthalate and bisphenol?
Hold on. You know there's phthalates in your water bottle?
Really? Phthalates? Did you know that there's bisphenol in your phone case?
Bisphenol?
Yeah. But it's even in your food container. But what are those?
But first, we're going to talk to you about phthalates.
Phthalates, a chemical used to make plastic more flexible and harder to break.
Hey guys, do you remember phthalates?
Did you know that phthalate intake can decrease your chances of having a baby? And if you are having a baby, it can cause asthma or behavioral issues.
Phthalates can also damage organs such as kidneys and lungs and give you cancer in those areas.
Imagine, you can get sick just from using products that contain phthalates.
Phthalates are usually disguised in the labels as fragrance. Bisphenol, a chemical used to harden plastic.
Let's take a second to talk about bisphenol.
Bisphenol affects both brain functions and hormones and can also cause cancer and heart disease.
Bisphenol can also lead to obesity, early puberty, and brain alteration.
So now that you've heard all these bad things about plastic, do you still want to use plastic?
Of course not. That's like asking me if I want to get cancer.
Well, we're going to provide you with some solutions. We'll see you at Casulet.
Gosh, 3 for $10.99?
Excuse me, miss. Instead of buying all these water bottles, you can purchase one of these reusable water bottles and save yourself.
Instead of picking up these plastic plates that you're only going to use once, try picking up these paper plates. They're eco-friendly.
Hi, my name is Eugenia Polius. Here at Casulet, you will use boxes instead of plastic.
Hey, what are you guys doing?
We're saving the fishes. Saving the fishes is like saving ourselves.
What do you mean?
Well, if we pick up garbage, that means the fish won't eat them. And if the fish doesn't eat them, that means they won't die. Some more food! It's time to reduce the amount of plastic we use.
Okay. All right, so that leads me into my next Climate Steward project in 2016, where we looked at reducing the amount of plastics as a mechanism for reducing climate change. Okay, so if you think about it, plastics are made of petroleum products. Okay, so getting this stuff out, mining it, manufacturing it, and then transporting it from wherever it's made down here, all that is more energy, and energy generation causes carbon dioxide to go into our atmosphere. So that's the angle we got at, because this particular mini grant was for climate change. And we use plastics, reducing plastics, particularly the single-use plastics, as a mechanism to do that. So if you think about plastics here in the Virgin Islands, we don't have any recycling. All the plastics that we use go into our landfill. Our landfill is overflowing. EPA we're on a consent decree with them, yet we continue to generate all of these plastics, some of which we only use a moment or two, 5 minutes, 10 minutes, and then we throw it away and it sits in the landfill forever, if we're lucky. If we're not lucky, it gets out into the marine environment, where it is broken down into microplastics and eaten by the marine life, and could actually get into our diet as well. So I thought that plastics was something that we should take on. I often go by, I drive down the street and I see students trying to raise money for certain events, and they're trying to sell me a bottle. And I really want to support their event, but I can't support the use of single-use plastics. So what we did in this project is we had a whole section on plastics, different aspects of plastics, whether it's the chemicals in them or how it affects marine life or the garbage patches. And I was also, okay, so why we did it, because there's no recycling. and they have to be transported, and we use it all the time. So what we did is the grant allowed us to buy, I think I got over 500 of these. They say refill, not landfill. And the students went out to their peers at that school and other schools and got them to sign a pledge that they wouldn't use the disposable plastic bottles anymore. And if they did that, they received a reusable bottle. So that was part of what the program was. NOAA likes to always document what changes take place, and so we had to do a pre-test and post-test of attitude and knowledge. Then we did the education on plastics, and I think I have a list of what things we went over. And then we did some beach cleanups. They kept a weekly trash diary to try to document whether they were actually using less plastics as the program went by. And then again, I like to have students transmit information. So I allowed them, or I got them, we put together several presentations for the annual Earth Day Eco Fair. I think I've got some pictures of that. We'll go back to that. But this is what we talked about during the classroom presentations, why it's unsustainable, what it means to photo-degrade versus biodegrade. We talked about recycling, different types of plastics, where does it go, the Great Pacific Garbage Patch, as well as all the other ones, impacts to the marine environment, and health impacts. And then we talked about paper versus plastic. We discussed these issues. There was a great video that I showed them parts of that they seemed to relate well to. And then they designed their own presentations. There was, I think, 5 or 6 different groups. They all came up with their own presentations, and they presented them at the Eco Fair, which are younger kids. And these kids really paid attention. I got to thinking, are they going to listen to some old white lady or a young, person that looks like them? And so I think this is a great mechanism for transmitting this data to younger people and really getting them to listen. And I watched these kids while they were listening to these presentations, and they were really paying attention. So this seems to work well. So at the end, we had 2 videos that they made. 8 separate presentations on different aspects of plastic were developed. We did 5 coastal cleanups, 2 in-school presentations for the entire educational complex. And then we had 500 students pledge that they would stop using single-use plastics, or the water bottles anyway. Let's see if I can get this video to play. I hope it's a different one.
This is our planet. We should love and care for it. So why do we hurt this planet we live on by polluting it with plastic? Our planet is drowning in plastic pollution. This doesn't just affect us, but our animals as well. Both on land and sea. Plastics are killing and hurting our wildlife. This is the reality of plastic bag litter. In Australia, what you are seeing are the final moments of a dying bride's will. This whale has lost its fight for life. The cause of death? The whale's stomach was tightly packed with 6 square meters of plastic. Much of the plastics were shopping bags. Sea turtles are facing dire times as a result of human impact. A recent 20-year-long study, Sea the Wild, estimates more than 2 million turtles died in fishing gear. Sea turtles are air-breathing reptiles, and when they are caught in fishing gear, they can drown. Albatross are known as feathered giants and are found in the southern hemisphere. These birds have the longest wingspan of any birds. The wingspan goes up to 11 feet. Albatross goes out to sea to get food for their chicks, but mistakenly eat plastic. They come back and give the plastic to their chicks, which makes them sick, then they die. These are the results. Don't you think we should do something about this? It is really important to make new decisions and change our daily behaviors. We all need to come together. We are all connected on this great big planet we call our home. And it's up to each and every one of us to take care of our home.
So I thought by concentrating on eliminating single-use plastic would be a lot more effective than doing beach cleanups. In the past, we've done a lot of beach cleanups. But I tell my students, I said, you know, if you walk into a room where somebody has left the water running, what's the first thing you do? It's not mop the floor. That's what we're doing when we do coastal cleanups. We need to shut off the tap. We need to stop the flow of plastics into our landfill and our environment. So although I still do beach cleanups, we also work on campaigns to eliminate single-use plastics. I don't know if we want to see the next video, but just so you see some of the results that I was required to put into my project, the knowledge about plastics and climate change had increased significantly before and after the program. There was increased awareness and concern about climate change and plastic pollution, and the students reported that they're using less plastics and that they intended in the future to use less. We don't know if that's true or not. And we decreased the usage of water bottles, we believe, according to the surveys. So successful, I believe. This year, I also am continuing to do some work with the high school students. They helped me at the Eco Fair in April, again doing presentations for younger kids on various aspects of plastics. And more recently at the agricultural fair, they were there as well. I have a grant in to do another mini project. The program is no longer called Climate Stewards. Now with the new administration, climate is taken out of most of the programs. Now we call it the Planet Stewards program. And so I will be doing more education in the schools and doing more cleanups Cleanups has been a problem for a lot of students because, or teachers I should say, because they don't have transportation to get their students to the sites. So a lot of the funds that I will get in this project will go towards transportation so I can get students to the site and back. And also we have some microplastic research that's happening this summer with one of the graduate students, one of the students that are here at UVI. And so that's kind of exciting. We're looking more and more about what's out in the field. So that's what I'm doing. And does anybody have any questions?